what I'm going to do is I'm going to walk you through and show you how the cab air quality system actually works and what the various components of the system are. First thing I want to bring to your attention is actually inside the cab, and it's mounted to the window right here. This is a pressure monitor. What the pressure monitor does is it, on a real-time basis, when the machine is turned on, it comes on, and it monitors how much pressure is being generated by the air conditioning system and by our cab air quality system. And what that means is that we're pushing more air into the cab than is leaking out of the cab. So we've actually compressed the air in the cab and created pressure, and that air now is looking for a place to go. So that air is going to find cracks and crevices in the cab, and it's going to leak out of the cab. The idea is that if there's things in the cab, we want them to be going out. We don't want to be taking stuff that's outside of the cab and be sucking it into the cab, into those cracks. So henceforth the reason for the positive pressurization. Okay, so this is telling us that at the moment we've got 0.65 inches of water column of pressure inside of the cab, which is very good. Now, I'm going to describe to you, there's two ways that we address the airflow inside the cab. And we have two systems here. One system is a fresh air system. The fresh air system our system has a motor inside of it, and it's a fan motor, and it's going to draw the air into this side. We have a rain cap here. The rain cap is designed to keep things from getting inside of the system, like rain, like birds or any hands, whatever. And we're going to draw the air in past the rain cap. It's going to be taken around the filter, which we'll look at in a moment, and it's taken out of the system through the outlet. What's happening is we're bringing the air in. We're going to take it through a pre-cleaning process inside of the device. We're going to eject the dirt out of these two slots coming down right here. And then the clean air is going to go through a filter, and it's going to be pushed through the air inlet into the air conditioning system. Okay, so the idea is to take the particles, take the dirt out of the air when the dirt is outside of the cab, and leave the dirt outside of the cab, and then put the cleaned air through the filter, and then the filtered air into the air conditioning system. If we can accomplish that, we can keep the air conditioning system clean and keep it operational over an extended period of time. Now, the second issue we have to contend with is the recirculation of the air inside of the cab. When we push air into the cab, we have to bring that air back into the air conditioning system so that it can be recirculated in the cab, or else we'd be pushing clean air or outside air all the time, and we'd run out of space inside the cab. You've got to take the air out as well as putting the air in. So we're going to do that on a controlled basis. But we're very cognizant of how the airflow takes place inside the cab. We want the air to start up around the operator's head clean. We want the air to flow down clean over the operator's head. And as it gets down towards the midsection and the bottom of the lower half of the operator around his feet, that's where you're going to have the most dust and dirt, because he's opened the door, he's coming with dirty shoes, the dirt's falling, and that dirt's being collected around the bottom. So that's the dirt. We want to take as much of that particulate out of the cab as possible, and we don't want to bring it back into the air conditioner, because if we did, it would come back over his head. So we've created an outlet down here at the bottom of the cab, and we're going to draw the air out from the foot of the operator, where we have the most amount of particulate in the cab. We're going to draw it through our recirculation RESPA system, and we're going to draw it in using a motor. So we're actually drawing it out of the bottom of the cab using a motorized system, a fan motor. We're going to bring it through the filter, and we're going to take the filtered air, and we're going to take it back into the air conditioning system. So in one pass through the cab, the air is going to go through a filter system. We're able to recirculate all of the air in the cab every minute or two. So we're gonna over a period of time, we're going to actually improve the quality of the air continuously after the door is shut and the cab is sealed. Because all of the air, whether it's coming in from the outside or coming in on the recirculation side, is continuously being filtered. And we're filtering it down to a very, very fine level. We're going below a half a micron, down to about 0.3 microns in size at a very, very high efficiency. So this allows us to produce a very high air quality. Now, the way that we prove this in our system after we clean the fresh air and the recirculation air is we've demonstrated this in our test by showing you what happens. Now, we're in a very clean environment here relative to being out on a job site. We're indoors. We're not exposed to a lot of free-flowing dirt flowing through the air like you would on the job. But what we've done is we've created a system here to monitor the difference between the inside air and the outside air as it relates to the particles which are floating in it. And what we've done on the outside air is we're saying we have a collector here that's collecting the outside air. It's taking little puffs, sucking in little puffs of outside air, counting the number of particles that are in it, averaging those counts, and giving us a total. It's doing the same thing on the inside air. We have a little collector on the inside. It does exactly the same thing. Now, in this case, once again, we're in a very clean environment. We're still in the room. It's showing us that we have 111,510 particles per million that are greater than 1/2 micron in size. On the inside of the cab, we have 46,350 particles greater than 1/2 micron inside the cab. Now, the longer we run our recirculation system on the cab, the lower this number goes. Okay? It'll never get to zero for a lot of reasons, but when you're talking about particles at that size and this sensitivity and the level of sensitivity that we have in counting those particles, you can appreciate that there's a big difference in these two numbers. And it gets more accentuated when you're outside and there's a lot of dirt flowing in the air. This number is going to get very, very high because you're exposed to a lot of dirt. This number never really changes. As long as the door is shut, there's no way that the dirt can get in the cab because we're pushing the air out of the cab, and we're filtering the recirculation air, and we're filtering the fresh air at a very high rate, at a very high efficiency. So that explains in toto the cab air quality system is a combination of a pressure, which we're continuously monitoring to make sure that the cab has got pressurization, and we're monitoring monitoring, in this case, in this test case, we're showing you for demonstration purposes what the particle counts are, and we're accomplishing all of this with a comprehensive recirculation and fresh air system. And that is the RESPA cab air quality system.